Now, decision trees can be used for binary classification. They can also be used for multi-class classification with basically no modifications. So, for example, let's say that in the same setting, you're given an input as a loan application. We have a classifier that tries to predict an output, but it's not just whether loans are safe or risky, but some loans I just don't even think about it. Danger, 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 don't touch them. So the question is, how do we make a decision whether a loan is safe, risky, or danger? Let's see an example of three-class classification here. And we'll see a decision stump, but the same thing applies to a bigger decision tree. So as input, we're given a data set. For example, we might have only one feature credit, and the credit can have those three values, excellent, fair, and poor. And then the output here can be safe, risky, or danger. If you look at the root here, you'll see that there's now three possible categories: safe loans, risky loans, and danger loans. And if you split on credit, we'll see pretty naturally that some of these loans fall in the excellent bin, some fall in the fair bin, some fall in the poor bin. And the ones that fall in the excellent bin, you see that the majority here are safe, so we predict safe. For the fair bin, we see that the majority is risky, so we predict risky. But for the poor credit bin, the majority is dangerous, so we don't even touch those. We discussed that we can make predictions based on the majority class for each one of these splits here, but it turns out that with decision trees, if you want to predict the probability of a class, it's actually very simple as well. So all you have to do is look at the fraction of the data that is associated with a particular label or value for each one of these leaves. So for example, for this case here, where credit was poor, where we predicted the y hat was danger, we can actually ask for the probability of danger given the input x. And in our case here, we'd say that if your input takes you down this branch, then 7 out of, 11 of the data points are dangerous. So we say that the probability of danger is 0.64. While, say, the probability of safe loan is 3 out of 11. So there's a way for us to predict both probabilities and the actual value of the outcome. And both are very useful in practice.